Okay, hi, we are Team B Medical Engineers from Georgia Tech, and we are working on the automatic suction device. So the problem we decided to address was that post-surgical babies in low resource settings are at a very high risk of aspiration or choking on excess bile, which could also lead to death. This is due to the fact that after an abdominal surgery, the intestines are unable to process fluids, and excess bile from the small intestines may build up in the stomach, overwhelming the body. The current solution to this issue has the baby's mothers occasionally suction the fluids through a nasogastric tube using a syringe. However, the main problem with the solution is that the suctioning is completely reliant on the mothers, which is both inconvenient and sometimes unreliable.
So when making our product, we had to consider many users. The first would be the manufacturers, and they need it to be easy to create and assemble with the pre-existing materials, especially in the low resource settings. Secondly, the doctors need the materials to be, or the device to be affordable and easy to teach others to use. And third, the mothers of the babies need the device to be intuitive to operate and be automatic as well, which is the prompt. And fourth, the babies need the device to both suction out their bile while not suctioning out their stomach lining. So to start creating our device, we created a problem statement first. Mothers of babies who have undergone abdominal surgery in low resource settings need a safe, affordable, and automatic suction device in order to prevent fatalities due to bile buildup in the babies. And to further break down our objectives, we had three constraints. The first, for safety, we need the suction force to be between 60 to 100 millimeters of mercury with manual backup operation in case the automatic system fails. Second, affordability. So the device should be under $100 and be able to be repurposed through pre-existing resources to further reduce manufacturing costs. And third, automatic. So that has intuitive operation and has less than 4 parts and is simple to use.
Okay, so we based our design off of the MedSource manual suction pump, but optimized it through a handle and gear mechanical system. About 1 meter of nasogastric tube extended out of the baby's nose will be connected to the suction pump. A support of ABS plastic from the platform on either side of the handle keeps the pump upright and attached to the platform. So this part is the blue bar that's just on the handle part of the device. The pump's handle can be pressed to suction out the fluids, which works similarly to the syringe. To automate the pump, we then created a control unit using a hooked metal bar, gear, and motor system controlled by 3 buttons. The hooked metal bar is moved with the gears to press the handle of the pump. For the device to be used, the mom should first press the green button. Then for the next 2 hours, the mom should press the yellow button every time that the suction bottle handle needs to be pressed so that the fluids can be removed. After the 2 hours pass, she should press the red button. From there, the control unit will remove fluids at the same time intervals the mom did during the 2 hours until she needs to change the time intervals of the suctioning. We recommend the device to be recalibrated every 10 hours or twice a day to account for any changes like increasing or decreasing in the amount of fluid in the baby's stomach. This design allows for the suctioning to not be completely reliant on the mother. And then these 2 images are the part of our design in which we show how we imagine the metal hook, gear, and motor system to look like and attach to each other.
Okay, so to get into the logistics of our design, we looked into the materials, pricing, and safety considerations. In reference to the materials, a polyurethane tube is used to transfer fluids from the stomach to the MedSource manual suction pump, which is all being supported on a wooden base. The control unit is made of plastic for most of it, and steel is used for the gears and the metal bar that pushes on the pump handle. We choose to use more mechanical items rather than electrical ones due to the problem targeting low resource settings so that we could reduce the overall price. With the materials that we picked and through sourcing components online, we calculated that the device would cost about $40 to $70, assuming this is 75% of final manufacturing cost. The main safety considerations included upsetting the stomach lining with too much suction, which is addressed by using a suction device that uses low suction power. With further testing also, the size and power of the suctioning pump will be adjusted if necessary. And another concern that was addressed is regarding whether the machine would malfunction or not. And for such instances, the suction bottle is detachable if needed, it could be just removed. So thank you for listening to the logistics and the project and the set of references.